In this class we are going to discuss about full subtractor. By using full subtractor we can perform difference between 3 bits. So initially we are having half subtractor, but by using half subtractor we can perform subtraction between 2 single bit numbers. If any borrow is occurred to the next bit, then we need to perform the subtraction between 3 bits, then half subtractor is not going to perform that operation. For example, if you are having A like 0, 0, 1 and B like 0, 1, 0, like this, if you are having 2 multi-bit numbers. So here if you want to perform subtraction of B from A, what's going to happen by using half adder means, actually we can use 3 half adders for this, for each corresponding subtraction. And after completing this 1 minus 0, it can be done by the half subtractor. So like 1, 0 minus 1, we need to consider 1 with borrow 1. So when third bit came, for third half subtractor, it is impossible to perform subtraction. So among these 3 bits, that is the limitation of half adder. This particular limitation can be overcome by this full subtractor. So see here, full subtractor is a combinational circuit used to perform subtraction among 3 bits. So here you can say this is the block diagram of full subtractor, which is having 2 input bits with a borrow input. So here these two are the 2 single bit numbers, and here this is borrow in. So totally we are having 3 inputs for a full subtractor. Similarly, we are having 2 outputs for a full subtractor. That 2 outputs may be difference and borrow out. So here to design this functionality, so we are going to consider truth table to satisfy full subtraction. So here I am taking truth table with 3 input variables with A and B in, borrow in. So totally, as you are having 3 input variables, so in truth table also you need to mention all 3 input variables for that circuit. So here I mentioned all 3 variables. With 3 input variables we may have 8 combinations. That 8 combinations is from 0 to 7. So I considered all possible 8 combinations for these 3 input variables. Now we need to perform the subtraction operation between each combination. So here when you had borrow in any subtraction, then you need to put borrow 1 in this place, otherwise borrow is 0. Here you need to perform every time A minus B, after that result is taken minus with B in. So here for example, first step I am doing 0 minus 0, the result is 0, again 0 minus 0, the result is 0. So here the difference is 0 by considering 2 cases difference. So here the difference is 0. So here in this case, are you hearing any borrow means no. So just put 0 in B out case. Now in the same way, so 0 minus 0, the difference up to there is 0. After that, the difference is again getting difference with 1, that means 0 minus 1. When you are having 0 minus 1, your difference is 1 and your borrow is 1. So here difference is 1 and borrow is 1. So now here 0, 1, 0 is there. 0, 1, 0 means first you need to consider 0 minus 1. In this 0 minus 1, your difference, whenever 0 minus 1 we are doing, you are getting difference 1 and borrow 1. So that borrow you just mention here, this difference, whatever difference is there, that you just make in your mind, and after completing next subtraction you just put the difference. So after doing 0 minus 1, you are having your difference 1 and borrow 1. When you had borrow, then definitely you just put borrow there. So after that, this difference again you just subtract with this 0, that means 1 minus 0. 1 minus 0 means you are getting 1 here. So now 0 minus 1, difference is 1, borrow 1. That difference 1 is again subtracted with this 1, that means you are getting 0 here. So now this case 1, 0, 0, 1 minus 0 is equivalent to 1. that one again we are subtracting. So 1 minus 0, again you are getting 1. 1 minus 0, 1, that 1 minus 0 is equivalent to 1. You are not hearing any borrow here. So you are taking borrow as 0. So here last case, last but one case is, so here 1 minus 0, you are having difference 1. So again you are doing 1 minus 1 means difference goes to 0. In any case you are not hearing any borrow means you need to put 0 in borrow place. And here 1 minus 1 you are having 0, 0 minus 0 you are having 0. So in this case also difference became 0, and borrow you are not hearing any case of subtraction. So you just put 0 in borrow place. So see here 1 minus 1 0, difference became 0 here, and that 0 minus 1 if you take in, then you are getting difference 1 and borrow as 1. So you completed the subtraction, your required full subtraction procedure among 3 bits. So after completing this difference and borrow out, you need to consider k-maps for both difference and borrow out. I am considering my k-map for difference. So here I am considering k-map for difference. So how many variable k-map you need to consider means, that is dependent upon the number of input variables. Here we are having 3 input variables A, B and B in. So in terms of A, B and B in, you need to consider your 3 variable k-map. I am taking 3 variable k-map with 8 cells. So this is 3 variable k-map with 8 cells. So here I am considering A, here B, B in I am considering. So as you are having single variable here, here the possibility is 0, 1 and top side 0, 0, 0, 1, 1, 0 and 1, 1. Now our turn is to put number of ones in this k-map. So where as you are doing k-map for difference, you need to see this line of difference. So where your difference is 1 means here itself, here you are having 1. So where means A equal to 0, BB is equal to 0, 1. So here A is equal to 0, B, B in is equal to 0, 1 means, so here you are having 1. And then another one is here, that means A equal to 0, B, B in is equal to 1, 0. A equal to 0, B, B in is equal to 1, 0 means, so that is here. And then you are having another one at A is equal to 1 and B, B in both zeros. A is equal to 1, B, B in both zeros means this will become the combination cell. So here you are having 1. And after that finally you are having 1 at all ones place. So here and here this cell becomes the combination cell of A is equal to 1, B, B in is equal to 1, 1. So here you are having 1. See here, total diagonal is covered in this k-map. As I told you in the last classes also, if total diagonal is covered, you can take XR of the variables in k-map. So this may be is equal to, that means D is equal to, difference is equal to A XR, B XR, B in. So this is the resultant expression from this k-map for difference. In the same way, I am going to consider k-map for B in. So that means input, output. You need to consider k-map for B out, that means output borrow. So as you take an input borrow here, you need to mention output borrow as B out. So now how many variable k-map you need to consider means, again 3 variable k-map you need to consider, because this borrow out is also came from 3 input variables only. So here I am considering those variables like in the same way as we considered for difference, I am considering in the same way. So see here I am taking the combinations 0, 0, 0, 1, 1, 0 and 1, 1 here and 0, 1 here. So now see here, so where your B out is equivalent to 1. So your B out is equivalent to 1 here, and that means A equal to 0, B, B in equal to 0, 1. A equal to 0, B, B in equal to 0, 1 means here, and then here that means A equal to 0, 1, 0. A equal to 0, 1, 0 means here, and here A equal to 0, 1, 1. That means here A equal to 0, 1, 1 means here. And then finally it is 1 at all ones place, that means A equal to 1, 1, 1 here. So we completed, we placed all ones at all possibilities. So here after placing ones in K-map we need to group. Is there any quarter possible? Means no quarter is possible, only doubles are possible. I am grouping into 3 doubles. So here is a double, here is a double, and here also we are having double. So now I am going to take these prime implicant values. So I am taking this vertical prime implicant. So this is top side covering, single cell you can take as it is, sidewise there is no combination. So top side, that is equivalent to B, B in. So plus another prime implicant value. So this one is sidewise it is covering A bar, top wise combination is 1, that is 1 is nothing but B here. So A bar B is the value of this horizontal prime implicant, and then finally you are taking next prime implicant value with the addition of these 2 prime implicants. So this one is equivalent to sidewise A bar, top wise 1 is in combination, that one represents B in. So A bar B in will come. So this is the expression for your bar out. Now after getting 2 output variables and their expressions, you need to consider the logic diagram for these output variables. See here I am going to draw my logic diagram. How many inputs are there? Means we are having 3 inputs, A, B and B in, borrow in. So you need a inverter for A because sometimes you are taking A bar in this expression, that is why I enabled inverter line also. So see here, if how you are getting difference means by taking XOR of 3 inputs. So just by taking XOR of 3 inputs you are getting your difference in full subtractor. So how you are getting your borrow out means B, B in, A bar B, A bar B in combination you need to add with a OR gate. First of all you need to take AND gate of all this, and after that those AND gate outputs are given to OR gate. So B, B in I am going to draw here. So with AND gate, after that A bar B I am taking. A bar means you need to drag from inverter line A bar and capital B. So now finally A bar B in. A bar means again from here and B in means this line. So all you need to add by using a OR gate. So then you are getting your borrow out from full subtractor. This is the logic circuit you designed for full subtractor using designing steps. So first you need to consider truth table and then K-maps. By using expression from K-maps you are going to design this logic circuit. This is about full subtractor.